All right, so here we're supposed to identify which of the following statements are true. Well, we have first one, f prime of x is greater than 0 for x less than 2, f prime of x is greater than 0 for x greater than 2, and f prime of x is equal to 0 for x equals 2. All right, so let's look at each of these conditions. So for less than 2, so we're going to go on this side first. The derivative is positive. Well, if we think about that, if we take all these tangents, they're going to be equal to a positive number. So for the first one, I, that's true. What about I? For greater than 2, it says it's also going to be positive. Well, again, it stays positive, goes to 0, then goes back to positive. So I would say that's true as well. Now here, f prime of x is equal to 0 at x equals 2. Well, that's just kind of like what we just drew in this last one. We said, if we go through there at the x equals 3, that would give us a horizontal tangent line, which is given us equals 0. So I would say in the last case, that is going to be true as well, because that's going to give us the horizontal tangent, which is going to be equal to 0 at x equals 2. Now, what about this one? Well, we have I, and I. Okay, so for less than 2, so going this direction, is it going to have a positive slope tangent? Well, if we go through here, that's positive, that's positive, that's positive. So yeah, it looks like it's going to be a positive no matter what. Now here, it's going up, 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 up. So it looks like that one's true as well. Now, is it equal to 0 at x equals 2? Well, at this one, we have that disconnect. We're going up to positive infinity here, going down to negative infinity here. So there's that vertical asymptote here, and so it's not equal to 0 there. So I would say that one was false, okay? And basically, it's because we don't have, it does not exist at x equals 2. We don't have a derivative at that point. Right, what about this one? So now we're throwing a little bit of curve here. Now we're doing less than 0 before we did greater than 0. So these are looking for, the negative slopes. So let's look at these. We'll have I1, and I. So we're starting at this point here. We're going left and we're going right. So is the derivatives less than 0 for this? Well, here they're positive. So as we go up here, every time we take a tangent, it's going to be positive. So I would say false for that one. Okay. All right, what about the next one? Well, the next one is this one less than 0 for greater than 2. Well, now we're going down. That's negative. So yeah, that looks true. And equals 0 for x equals 2. Well, yeah, I would say that's true as well, because we're going to have that horizontal line at x equals 2. Okay. What about the next one? Is it less than, well, let's write our and I. So is it less than 0 on the left? Well, no, that's going positive going that way. So I would say that's false. Now, is it less than 0 on the other direction? Yeah, those are all going to give us negative slopes for tangent. So yes, that's true. Now, equals 0. Well, here again, guess what? We have asymptote here. So that's going to be false. It does not exist at x equals 2. Okay, so we don't even have to worry about that one. It doesn't work there. Okay. All right, so that's kind of how you have to look at these. We have to think about, how does the slope of a tangent line look at each of the points, and does it fit the criteria given here? All right, so let's pause there, and then we'll come back, and I think we have to draw some graphs now.